Problem number 6 has a couple different levels of difficulty that they could take on. In its present state, I would say you could really make this a pretty simple problem and not go through the outline statements that I have here. But as they progress and get more complicated, you may have to use that result or that strategy. So I'm writing down the two equations they gave us to start off with. We want to end up figuring out what p squared plus q squared is. So don't forget we've got to finalize what we do. I have a lot of students that will get the values of p and q and forget to finalize them as p squared plus q squared. So here's where this problem can become fairly easy. If we look at this expression, we could simplify this into p times q equals 4. All I did is I divided both sides by 2. That makes it a little bit easier to identify. I'm looking for two numbers I can multiply together, and their product is 4. But yet when I compare the other thing that I have to satisfy, these same two numbers have to have a sum of 5. So here's where I think that sometimes we can save ourselves some time on the ACT. If we can do these mentally, we could probably generate our answers pretty quickly. There's a very limited number of factors of 4. It's either 2 times 2 or 1 times 4. They both give us 4. But only one of these pairs, if we add them, give us 5. 2 plus 2 and 1 plus 4. That gives us a 4, that gives us a 5. So there's only one set of numbers that we have that give us a sum of 5, like this equation requires, and a product of 4 is this one. So really what I've already determined in a very short time here is that p is equal to 1 and q is equal to 4, or it really doesn't matter since we can turn the order around. P could really equal a 4 and q could equal a 1. In either respect, when we square these and we plug them back into our final answer here, we want to take p squared plus q squared and find our value. So if we choose p as a 1, that's 1 squared plus, and that means q would have to be a 4. 4 squared, we get 1 plus, now that's kind of in the way, so let me slide down, 1 plus 16, or 17. 17 is our final answer. It wouldn't matter if I plug these in crisscross that way. I'd still get 17. So that's how I can get that done in a relatively short amount of time, just by using some number sense along with that. If they happen to get more complicated, sometimes they will. This one wasn't. You might want to review some of your substitution strategies. So I'm going to show you that quick, or as quickly as I can, and move on. So we've got 2 times p times q equals 8. I am going to simplify just like I did before. I'm going to divide both sides by 2, which means p times q has to equal 4. So now what we're going to do is use a substitution principle. I want to get rid of one of these. I'm going to get rid of p. So that means I'm going to take this equation and solve it for p. So p is equal to, if I subtract q, 5 minus q. So what I'm doing is rehearsing the substitution principle. Solve one equation for one of your variables and plug it back in. So I'm taking this 5 minus q and I'm going to replace p in my second equation with that result, which means p now becomes 5 minus q times q equals 4. And this becomes a lot more mathematically rich when you look at what I'm going to do versus what I did the first time, because now in order to solve this equation, is 5 times q minus q squared with the distributive property equals 4. Which means if I'm going to solve this, since it's a quadratic, I want to get one side equal to 0, and I'd rather get the left side equal to 0 and make my quadratic term positive. So I'm going to add the q squared, I'm going to subtract the 5q, and plus 4. Now I have a quadratic equation, which we have gone over in this same practice set. How to solve? We can use quadratic formula, we can factor. This problem is relatively simple to factor. Q squared has to be q and q. The signs have to be the same. They both have to be negative, so minus minus. Factors of 4 that add up to a 5 is minus 4 minus 1. If those are the factors, then I know what I need in order to generate an answer of 0. One of these two numbers or expressions has to equal 0. So in order for this to equal 0, q would have to equal a positive 1. Or my other option is, what could I put in for q to get this to equal 0, which would be a 4, or a positive 4. So my two solutions, again, are q being a positive 1 or a positive 4. And we don't have to be too overly concerned about this, because q can either be a positive 1 or positive 4, which means if I'm looking for p was a result of 5 minus q. And q can take on two different values. The first time it could take on a value of 1, which would force P to be equal to 4. And then the second time I can go back through and say 5 minus Q, and this time put in the 4, so it's going to be 5 minus 4 equals a 1. So in either case, we get the same combination of numbers. When P is a 4, Q has to be a 1. If P is going to be a 1, then Q has to be a 4. And in either case, we take both of these and square them, we're back to 17. So, like I said, it can be really simple, as in the case the first time I showed you, or it could get a little more complicated, which would force you to go through some strategies of substitution principles.